Hello everybody and welcome to today's Happy Maths Hour. The topic is playing fraction games. So we're going to learn a lot about fractions by playing the games.
It's such a troublesome subject to teach and learn. So many children hate fractions, and it's because they don't understand why they've got to do this and that, turn something upside down and multiply instead of dividing. They learn these rules and the rules don't make any sense. So on the Aiming High website, we have got a collection of fraction activities and games. And if the children are taught this way, they will understand fractions. They will take the fear out of fractions. Did you enjoy learning fractions? Did you hate learning fractions when you were at school? Let's look at fractions again. What we're going to do is we're going to talk about a fraction wall. And we're going to talk about building a fraction wall from bottom, which is a unit, and then smaller and smaller and smaller blocks as we build up the wall. And each block is a fraction of the unit. Now, in this picture, we've got a purple unit at the bottom, and then we've got two blue halves, and we've got three brown thirds and four green quarters. And then that color, which is a sort of rather shocking pink, I think, that one is sixths. And the next one is a lighter green, and so on. That's eighths, and so on. You can build your own fraction wall, color it, make it out of cardboard, whatever. And it's a really good thing to have on your classroom wall to remind children of these fractions. And it helps with equivalent fractions. What's the same as something else? All that about cancelling fractions that they are told the rules about. And it also helps to know, is this fraction bigger or smaller than that fraction? So did you enjoy learning fractions at school, Caroline?
I did. Fractions was one of those things, one of my lovely puzzles. I loved manipulating them and figuring out what goes where and how to add them. I found it very exciting, finding the correct common denominator. I was like, "Whoa, found it! Now it works."
Did you understand why when you divide a fraction by another fraction, you turn the second one upside down and multiply?
It was just an algorithm. I discovered it in my 40s that I actually didn't understand division of fractions. So yeah, it was just an algorithm. It was just a method.
Yeah, I mean, a lot of children do eventually understand adding fractions and subtracting. Multiplying is always easy; it's the obvious thing. But often they, as Caroline says, it's just an algorithm, just a rule. You do it, and if you're careful, you get the right answer. Yes. Okay. So here we go. Here is a puzzle, which at a glance it looks like the wall you've just seen or similar, but actually the strips are now in a muddled sort of order. They're not in the right order. So Caroline's got the strips. On this Aiming High activity called Fraction Wall Game, you can cut out the strips, and then you can the children can rearrange them to be with a unit at the bottom, and then the halves, and then the thirds and quarters and fifths and sixths and so on. So there's the puzzle. That's what it's about. It's quite easy to do. Possibly in the class, each child can have their own cut out strips and stick them in their book, and then write on each row 1, a half, a third, a quarter, a fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. So this only goes up to 12ths. It's the red ones are the 12ths, and that goes right on the top. And so they're quite narrow strips. You may want to make your own in your own way and make it with wider, chunkier strips, and have your fraction wall to refer to. Or you may just use this as a puzzle and make a fraction wall that's a solid thing and not cut up, and it's nice and neat and tidy.
It's good for assessment, isn't it, Toni? You can walk around and if the children are doing it in pairs, then it's really good to establish whether or not they're understanding what's happening.
We do believe that expensive equipment is absolutely not necessary, and you can make your own with scrap paper, scrap card, and a lot of the schools we work with as AIMSEC don't have money to buy equipment.
The idea is just a puzzle, and you can do this with quite young children because they are putting something in order. They don't even need to know what the fractions are or know that there are such things as fractions, because for them they're putting them in an order from the biggest one at the bottom, making them as they put the strips together. They want to be in order, getting smaller and smaller and smaller as you go up. So this is a prelude to learning the word fraction, okay, for little children. And another thing we like to do is to show how the same theme can goes right through our learning, and we keep adding to that theme. So this is an excellent way to lay the foundation the first time you really start to talk about fractions. You could just use the unit, the halves, and the quarters, and no more, and talk about what they were and how many quarters made a half and that sort of thing. Here's the same puzzle, but now we want to work downwards rather than upwards. That's the only difference. So Caroline is going to put the unit at the top now. Oh, she's got the unit at the top. The one that we were doing before, Caroline, had the unit at the bottom.
That is correct.
What we need now is exactly what you had a minute ago, and then you muddled them up. There you go. With this time with the 12th at the bottom. Okay. The last one, this one, we were supposed to do with the unit at the bottom, and then do it with the 12th at the bottom, as Caroline's now done. You see the right, which hasn't got as many layers in it, and then we want you to think about marking the scale on the bottom. Can you see 0 or 0 over 6, 1 over 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6? Well, on our wall that we're going to do with the puzzle, you can do that with 12ths, and so you mark it with 12ths as you go along there. You don't need to go all the way along, Caroline. I think we've got the idea. So are you up to? We can't actually see. That's 6/12. You've just written a 6. That's 6, I think. Is it 6/12? And then okay. So then now underneath that, do another scale. But now don't put 2/12. Think what is the equivalent fraction to 2/12? That's what we call cancelled or in its lowest terms. Well, you should see that 2/6. That 1/6 is the same as 2/12. So Caroline's going to write, instead of 2/12, she's going to write 1/6. And instead of 3/12, I think she should have written a quarter. I can't see. No, I don't think you got it right, Caroline, because it's 2/12 is a 6, 3/12 is a quarter, and 4/12 is a third. And I think you wrote them in the opposite order. You? Oh, no, you did get them right. So sorry. That's perfect, Caroline. Lovely. Okay. So there'll be a lot of talk and chat about that when you do it with young children, and you don't do it. I said the wrong thing. They do it with a little bit of coaxing from you as a parent or a teacher. These are called Multilink Cubes, and you can see it's a fraction wall again. This is a lovely thing to do with young children if you've got this these interlocking cubes that you can click together. You can do this with Lego as well. What you've got there, you see you've got unit. The halves are different colors, pink and brown as in this picture. The thirds are different colors, orange and yellow. The quarters, again, green and grey, and fifths and sixths. So that's a nice activity for young children with Multilink cubes. I'm going to tell you about chocolate fractions. This is a nice activity for young learners, and it's a story. So here's the story. Its writing I know is small, but I'm going to read it to you. Your granny bought a bar of chocolate marked into 32 pieces and weighing 180 grams. How many pieces make half the chocolate? How would you find that out? Caroline, could you break your bar in half? So the story goes on. How many pieces make 1/4? What fraction of the bar is one piece of chocolate? So these are little questions for the learners to answer, and it's a story. So that's Granny, gave you and your sister 2 pieces each to eat. Yummy. What fraction have you and your sister eaten? How many pieces are left? What fraction of the bar is that? Now, Granny needs 90 grams of chocolate to make a birthday cake for you for your birthday. Wow, that's exciting. How many pieces of chocolate will she use, and how many pieces will be left over? What fraction of the bar is left? Will there be enough chocolate for your family each to eat 2 pieces of chocolate, and if so, will there be any chocolate left after that? So there's the story, and there's one of a large collection of different activities on the Aiming High website, and they can download a worksheet, you can download the notes for teachers with solutions, and lots more on fractions on the Aiming High website, the Aiming High network we call it. Now we're coming to the double 6 game. What we're doing to play this game is you need 2 dice or a 1 to 6 spinner, and there Caroline has the wall, and the children will use the wall to compare the size of fractions. Now, Caroline, throw the dice. This is your throw, Caroline. Right, so you've got a 1 and a 2. Now, Caroline's got to make a fraction, putting the smaller number on top and the bigger number underneath. So her fraction is a half. Now, remember that, so she can show a half on the wall. Now, throw it for me, Caroline. My turn. Throw the dice for me, Caroline. And what have we got? One quarter. Yes, 1/4. And Caroline wins because this is the round. We both teams, both players throw and make fractions, and the bigger fraction wins. The larger fraction wins. So Caroline's won. Now throw again for you, Caroline. You've won that round. Now you have got 2 quarters. Now you've got to look at the quarters and decide what 2 quarters would be. The quarters are dark blue. So what do 2 dark blue pieces make? And you can see that 2 dark blue pieces are the same as a light blue piece, which is a half. So that's Caroline's fraction. Now my fraction, Caroline, is mine going to be bigger or smaller than yours? What have I got? I've got a half. Okay, so that's the same fraction. So that round was a draw. So in the first round, Caroline won, and in the second round, we were the same. We both got a half. It happened that way. Right, again, it's your turn again, Caroline. Now Caroline's got a third, and those are the sort of cream-coloured pieces, a third. Now, will you throw for me, Caroline, and see what I get? Caroline, is that dice a fair one? Because you keep, every time you seem to get a 1 and a something else, which is very odd. Oh, I think we did get a 2 once. Okay, so that's 1/2, and my fraction, which is a half, is bigger than Caroline's, which was a third, and I won that round. So shall we do it once more, Caroline? Just once. What have we got now? Oh my goodness! Why does one? It's a loaded die you've got there. Caroline has got a 6. I think I've got a very good chance of winning. Okay, Caroline. I've got the biggest possible. I've got 3/3. Okay, and my 3/3 is a whole unit, so I would have won that round. Really fair square, and certainly I would have been the winner there. So there you go. So this game is a game which even small children, even if there's some help with doing it, can learn to play and compare the fractions, as Caroline has put the strips there to seat and counted the halves, the thirds, the quarters, and to see which was the bigger fraction and which one won the game, or the round, not the whole game, but the round. And so this is a good game for 2 teams. So if there's a group of you, you can have Team A and Team B, or Team Toni and Team Caroline, and take it in turns, and one round is just 2 throws, and you see who's won. Or if you've got a small number of people and you're sitting around a table, then this can be a game that everybody joins in on their own behalf, rather than a team game, and you can pass the dice round and each person can throw the dice. Okay, so you can vary this, and here on this slide you see how to make a spinner. And now a spinner, all you need to then is to make the polygon which will have the right number on it. So supposing you've built a higher wall up to 9ths, okay, and so you need to find the numbers 1 up to, instead of 1 up to 6, this is 1 up to 9. And so you mark your polygon, which has 9 sides, with the numbers 1 to 9, and you need an ordinary paper clip, which you straighten out one end, and then you can use a thumbtack in the middle, or you can just hold the paper clip in the middle with a pencil, as you see on the picture there, and then you can just flick the paper clip, and it works really well. As it spins round, it will stop in one of those sectors, and that's your number. So you have to spin it twice to get the fraction. So rather than using 2 dice, you've got to spin twice. And you can, here, this is walls of different heights. So what I suggest is that if you're in school, as you're working with older children, as they move up the primary school, maybe into secondary school, you actually introduce more fractions here, and they will learn in an amusing way, a way they will enjoy. They will learn about equivalent fractions which are actually the same, and cancelling fractions, and they will learn about also comparing one fraction with another. I mean, is 2/3 bigger or smaller than 5/12, for example? So you can show that on the fraction wall, and you need to do it. You need to be able to find an answer to that question if those numbers come up in the game. And so it gives you a reason for wanting to have an answer to that. Otherwise, it's just a boring question. You know, is 2/3 bigger or smaller than 5/12? So what? What does it matter anyway? You know, just as an exercise, how boring. But if you need to know which is bigger, because if the bigger one wins the game, you've got a reason for asking that question, and you've got a reason for finding the right answer. Okay, so vary your fraction wall, building it higher, up to 20ths if you like, that's up to you. Make your own fraction wall. So here are some questions that you can ask. And these are questions to help the learners to understand how the wall works. You see a picture of the wall built correctly now.
As Toni knows, key questions are one of my favorite things. They are so powerful because you're not asking closed questions. You're not asking, is 5 + 5 10? The great thing about the key questions is that, and all the aiming high activities give you key questions to use. So if you're not sure or you're just learning to use them, you can just go onto the Aiming High website, and I'm going to put the key questions here in the visualizer because I don't think Toni's noticed. This is the craziest session we have ever done. I think we've had some crazy ones, but this is even crazier. So the key questions are open questions. What do you notice about the length of the different building blocks in the picture? And these questions are leading you to understanding, or helping you to lead the learner to understanding how many dark green blocks are there. So yes, that's a closed question, but these are leading you to understanding. So how many dark greens are there? How many of the orange blocks match the unit grey box? So how many of the orange are needed to match the unit grey block, which is the unit? So it's effectively the same question, but it's asked in a different way. And if the bottom, the grey block, is 1 unit, then what fraction is the purple block? So it's asking it in a different way. Instead of being really blunt with the questions, you're going to it slowly but surely. And then how many blocks of this color match how many blocks of that color? So you're looking at different colors, so they can choose two blocks of their own, and they might make discoveries. The 5 1 2 3 4 5. If they were unit blocks, would that go, and do they go into each other? And then this is a huge question at the end. How do you know? So it's not just a matter of asking the questions. It's a matter of, then please explain it to me. What is the answer and why? How do you know? And how do you know is a very powerful way of saying why. And if you say why, you can get a blank response. But if you say, how do you know? Then they'll start thinking about, well, how do I know? And they'll ask themselves that question, how do I know? Rather than why. It's like, whoa, why? I'm not sure. But how do I know? Is it open, so open to the point that you will actually get responses to how do you know?
Caroline, what do you think of this?
I love this activity. One of the things that distinguishes mathematics from everything else is that amazing ability to visualize and to go to infinity. We can't go to infinity in our lives. We can't go to infinity in distance, in time, in anything except in our heads. And this activity does two things. It helps you visualize fractions. So what you do is you keep on halving. You're aiming for the end of that bar, and you keep on halving. And number one, will you ever reach the end? But in the process, you're halving fractions. So you're doing some really interesting mathematics, which is also a binary progression, which is by the by, but it's a very useful observation. And it takes you to infinity. And I just love the fact that we can go to infinity by using our imaginations. And the reason why visualizing anything, estimating and visualizing in particular in mathematics is so important is that we need it to actually do the maths in a lot of cases, and this is one of them.
What you have here is adding an infinite sequence of fractions, as Caroline, I'm sure, has been telling you. What an abstract idea, an infinite sequence. And we're able to go to infinity in our minds. And so what we're doing is visualizing this limit. It's something that we talk about, the mind's eye. And there's an eye, and this has got Egyptian fractions in it. Now, what's Egyptian about those fractions? Well, you see, this exercise, this activity is all about adding 1 plus a half plus a quarter plus an eighth plus a 16th plus a 32nd plus a 64th, and on and on and on. And each one you add only takes you halfway to the end of this strip. But you get so close, and you get closer and closer in the limit, which I'm sure Caroline has just pointed out. And what you see in the eye there is written a half, a quarter, and then an 8 is in red, and a 16th is then inside the white of the eye. 1 over 64 is in green, and 1 over 32 comes first in blue, and then 1 over 64. Now, the Egyptians, that's called the Eye of Horus.
Apparently, I only just learned they didn't use fractions the way we do. They didn't have 5/6 and they didn't have 7/8. They only used the fractions that you see there. It had to be 1 over the fraction, which means that they were really, really, really good at adding fractions and working out the common denominator, because the only way they could work out 5/6 was to work out what fractions you had to add together with a 1 on top to make 5/6. And I suppose they could have added 5 1/6 together, but something tells me that they did things like adding a half and a 6 together to make not 6, but half and 2/3. No, that's 2/3. No, see, wouldn't be. It'd be half and 1 something, which isn't coming to me. But
Caroline's been explaining to you about Egyptian fractions. I think it's quite intriguing. They were very sophisticated people, and they obviously understood about fractions. But the way they used fractions made the whole process, the whole procedure, a little bit more difficult, I think, in some ways and easier in others. But anyway, that's Egyptian fractions for you. But there you are, and it's visualizing, and of course the sum of this infinite sequence becomes a series when you add up the terms, and the sum in the limit is 2. So this lovely strip isn't like the fraction wall that we built, but it's the same idea. We're using blocks to show the fractions, and these smaller and smaller blocks are in order, aren't they? And each one is half the previous one, and I've got a lovely demonstration there that this infinite sequence adds up the limit anyway. As the number of terms tends to infinity, the sum tends to 2. Just 2. The answer's simply 2. Isn't that just absolutely lovely? So we've enjoyed a lot of ideas about fractions. I hope you've enjoyed it too. There's lots of games to play, and the sorts of games that you can vary quite a bit and talk about and become more familiar, make friends with fractions. About time to say goodbye. Until next
Goodbye.
week.
For greater understanding and enjoyment of mathematics, the Maths Toys YouTube channel is brought to you by AIMSEC and the Aiming High website. In the description you will find a link to our home learning guide for ages 4 to 18 and a teacher resource pack. If you find this video useful, there is a GoFundMe link in the description to donate to and support AIMSEC. The money goes to bursaries for professional development for teachers in disadvantaged communities around the world. Subscribe, comment and ding the notification bell to make sure you don't miss our latest activities.